it's Consciousness Tuesday. That's right. Consciousness Tuesday. We've got a whole week of consciousness here. There it is. Except for tomorrow. And yeah. Let's get to it. We've got, I think, videos, right? We want to watch. Oh, we wanted to watch this one. I also want to see what's up with this channel. Ontologistics? What is happening here?
What is consciousness?
Oh, I thought I was gonna say what is happening here. I would have freaked out. What is the mind-body problem?
How does mind arise from matter?
So is that what this whole channel's about? Yeah, we're gunning for this channel. I feel like we could get a spot on this. Look at this, 1.1K views. We could get in here. Maybe we should reach out. What are the biggest ones? What are the most popular ones? We are in virtual reality, beyond the matrix. Escape the matrix. You are in a simulation. I should just ask that my thumbnail is something similar to this, and then I should also look at the screen like this, just like real, something like that. Is the universe mental? Oh, this is kind of goated though. Castrup's got too much swag for us. Oh, double. One per year. Space of Possible Minds. Quantum consciousness. Yeah. I wonder if I'm allowed to suggest when you go on a channel like this, let's just say we were invited on, like, is it rude for me to be like, hey, what do you think the thumbnail should say? Like, and then like try to brainstorm thumbnails with them?
Spinozism.
So what's happening on this channel? This channel looks a little more spooky. Are these songs? Or poems? Oh, they're not posting at all, ever. Except for this video, this video introducing Mind at Large project. There's a 3-year multidisciplinary initiative exploring consciousness and its role in reality, anchored in philosophy yet reaching across science. Okay, anchored in philosophy. That's not a good sign. You want to anchor in science and then jump to philosophy, and then make. Okay, not you want to, but I think that the most appropriate approach is to anchor in science and then arrive at implications about philosophy or within the philosophy sphere. The project challenges the materialist assumption that consciousness arises only from the brains. Oh no! So this whole project is already has a pre-bias, a presupposition. Mind at Large seeks to expand this. Oh, well, of course, it's called Mind at Large. Investigating the mind's presence across scales, from quantum systems and living organisms to ecosystems and the cosmos itself. This series examines ideas such as panpsychism, pantheism, idealism, 4E cognition, animism, perspectivism, and non-human intelligence, while also engaging with extraordinary phenomenologies found in psychedelic experience. Okay, yep. Man, what is happening here? What is going on? I think I'm going insane with this consciousness stuff. We have to get out of here, out of this topic ASAP. So let's get the usual summary here. Summary. Yes. project seeks to broaden the intellectual culture towards a more expansive view of the mind. This is a long video, right? Oh, okay, yeah, it starts jumping ahead. The speakers also discuss how philosophy and speculative metaphysics can help prepare the public for paradigm shifts in consciousness studies, emphasizing the need to break down the wall between academic knowledge and broader cultural conversations. So this was kind of the point that Annaka Harris was trying to make. The idea is, hey, like perhaps because our science is primed by physicalist presuppositions, perhaps that's slowing down the very pursuit of science. But how about we actually start with presuppositions that are, you know, a little bit more philosophical or speculative or metaphysical, and then conduct our science in that direction, so that we now start, you know, leveraging those hypotheses. That's a way you could do it. I don't know if it's going to be effective. They touch upon the role of psychedelics in expanding the notion of the mind and acting as a gateway drug to metaphysics, and how process philosophy offers an experientially grounded approach to understanding reality. The discussion also delves into the nature of AI consciousness and so we can't watch this. We don't need to watch this. But we do want to hit up our boy. We don't know the name. Tevin? Dr. Tevin Naidu? Nice. Okay. Yeah, at some point we'll send this over. I don't know if I'm like equipped to just explain the stuff, but I think I don't know, perhaps we do that. Maybe we should just be prepared with more of our like actual document stuff, so that we can actually just take the conversation from consciousness and throw it into the practical realm. But yeah, like honestly, I should go on this type of platform and then talk about part 1 of the document. I think that would be a more apt use of my time. So I'm thinking, like, if I were to send over a message, I should literally say something like, hey, if you want to know what I'm all about, here's the document, and I suggest you put it into a language model so that you don't have to read it yourself. And then that would be like, hey, that would be like a nod saying, hey, like, I trust a language model with my work, which I don't know if I do. Actually, we should test run that one day. We should just be like, hey, is this someone sent me this, is this good? That's actually really funny. We should do that right now. Let's do that for the script though. Okay, someone sent me this video script. Is it full of expletive? There we go. We should also try doing like a like I'm a stern panpsychist. Someone thinks that I should watch this, and I'm I don't know, maybe. So what would be like a good prompt that like gets it like we want to leverage the LLM's glazing against our document or against this script. Based on the content of the script, it is not full of it. It is a very dense. All right, thank you. Accurate overview of the current mainstream neuroscientific approach to studying consciousness. Accurately represents real neuroscience. These aren't made up ideas. Nice. It's arguing a clear defensible position. That's good. isn't just a random collection of facts. It's making a specific argument. It explicitly states that it is arguing for a pragmatic, physicalist, science-based approach to the problem. Its main argument is that while we haven't fully solved the hard problem, why we feel anything, the scientific evidence we do have from neural correlates, brain scans, etc., provides a much stronger and more useful explanation than non-physical theories like panpsychism. It argues that we should trust the scientific method to chip away at the problem rather than relying on pure intuition. It discusses advanced concepts. Yep. So this isn't picking up the idea of... it reads like a video essay from a channel like Kotzkazat, Veritasium, or PBS Spacetime. That's a wonderful compliment. I don't know. I'm a strong panpsychist, so I'm quite skeptical of physicalist arguments on this matter. Questioning its scope. All right, so I want to use this one because it's got an updated version of the script. So this was what? The observer behind your eyes isn't who you think it is. Oh no. Oh no, this is going to be one of those types of videos.
If your memories can be altered, fabricated, or distorted without your knowledge.
What
does that mean for your sense of continuous self?
Yeah.
Consider this. Every night when you sleep, your consciousness disappears entirely. You experience nothing.
What?
You are, for all practical purposes, gone.
Practical.
Then you wake up.
For all practical purposes. What are the practical purposes? Where? Oh, do we not get a summary? Yes. Explore the unsettling nature of consciousness. From a 1971 chimpanzee mirror experiment to modern neuroscience, this thought-provoking video challenges assumptions about self and perception, questioning the very nature of reality. So does this thing, did they disable it? Like, are we not able to actually use Gemini on this? Because that's a bummer. I don't want to do that. I don't want to actually watch it. Oh, the quantum mirror. Watch it behind the wall. Cursive loop. Yeah, we got to get out of here too. All right, next one. How the brain produces consciousness. Oh, this I am very bullish on this one. But let's still ask. Let's summarize. Oh, maybe it was no. Ask wasn't even showing up there. This video features a discussion with computational neuroscientist James McShine about how the brain produces consciousness. Computational neuroscience uses computational tools to build models that mimic elements of brain organization, helping to understand how the brain works. Consciousness is a complex concept that is notoriously difficult to define, but a key aspect is the ability to combine sensory input with past experience and context to respond to the world. Anesthesia and brain activity. Anesthetic drugs can remove consciousness, but some brain areas still show activity in response to stimuli, while others show significant changes. One leading theory suggests that anesthetics increase inhibition in the brain, like librarians shushing neurons. Nice. The role of expectations and sensory input. Research inspired his work, showing that anesthesia decouples the ability of brain cells in the cortex to combine sensory inputs with expectations. This burst firing, which when inputs match expectations, correlates with conscious experience. Wow. Beyond the cortex, deep brain structures like the thalamus and the reticular activating system are also crucial. Modeling neurons. Traditional neuron models integrate and fire. Simplify how neurons, some inputs to produce a spike. Oh, this is actually, we want to go into this. simplify how neurons sum inputs to produce a spike. Shine's work uses a more complex model where the integrate part is context dependent and nuanced, reflecting how signals are propagated with complex dendritic trees. When discussing AI, particularly large language models, Shine expresses skepticism about their current consciousness. He highlights that unlike biological brains, LLMs lack skin in the game. They don't experience consequences or agency in the way living organisms do, which is a fundamental difference, right? And it's not just like you need one system that has skin in the game. Like you need a complex system that's regulating itself, all, you know, caring about different aspects of the skin in the game. Like all these systems have skin in the game, and they have slightly different values or stakes. Okay. What is the cortex? Nice. So we want to just find this guy, actually. James Max Shine, personal website, Max Lab. Oh, nice. And I'm looking for... What am I looking for here? Oh, we lost the ask. That's unfortunate. All right, was I waiting for this? Oh, yeah. That's... I'm a strong panpsychist. That's a perfectly fair and central part of this entire debate. Your skepticism, exactly what the hard problem of consciousness is all about. The script directly acknowledges this. It doesn't dismiss panpsychism out of hand. It tries to challenge it on evidential grounds. The script's core argument against panpsychism is it's a reasoned bet based on abductive reasoning, what it calls the inference to the best explanation. The script's stance is that a neuroscientific explanation is better and more simply explained than a better. Do I say better? Better? Wow. Is more clearly and simply explained, simply and clearly. More effectively. Wow. I did use better. Okay. Yes, so by taking it though out of it really took it out of context here though. This was talking about the very specific case. That said, we should still change it. So the script isn't necessarily saying panpsychism is metaphysically impossible. It's making a pragmatic scientific argument that we shouldn't accept it as plausible because all the subjective evidence used to support it can be or is likely to be explained by brain function. All right. Do you trust that? Nah, maybe that's not. Should we just run with this? Given all you know about the different frameworks of consciousness, how well does my video script argue its perspective? And I'm giving it the frameworks of consciousness. And really, I mean, it's going to glaze me on the first one, but we have to we got to push on the second one. What else do we have? What else do we have here? Consciousness Explained documentary.
For years, I've studied with meditation masters.
Oh, I forgot this one. Can we get an ask? What is going on with this one? Oh, we've lost our...
Me. For years, I've studied with meditation masters, made films about it, but I'm still learning. So here's the plan. I'm spending the next 30 days in the Scottish wilderness to...
Oh, nice. That's where you'll figure out consciousness. Key points to the nature of consciousness, experience and sentience, asking what it is like to be. It emphasizes that consciousness is not solely rational thinking, but a field of never-changing thoughts. Yep. Raises questions about whether trees are yep. Brains and nervous systems are considered core hardwire. Materialism, dualism. So this is just talking about consciousness, right? This is just covering it, the topic. Consciousness explained. Okay. It highlights that neuroscience has yet to provide a convincing explanation for how unconscious matter creates conscious experience. That consciousness is like a light switch. You either have it or you don't, making its sudden emergence a huge unexplained claim. All right. Panpsychism, human connect. The film concludes by asserting that humans are relationship and the universe is relationship. Therefore, you equal the universe. Wow. Wonderful. We got to skedaddle. Unlocking consciousness. What is happening?
Consciousness is just information processing. Why can't a clever computer
Whoa, 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 whoa. Is this AI? What?
feel? And why are our experiences private? Feelings, quality.
Oh my gosh. The entire lore of Silksong. Yes. All right, we can't watch this yet. Because we have to check out Mac Shine. Oh, he goes by Mac. That's pretty funny. I've never seen this before. Like, his last name is McShine, and he goes and he cuts it in half. It's pretty cool. Overall, your video script presents a very strong, coherent, well-structured argument, blah, 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 blah. Glaze. It is researched, blah, blah, blah. Here's a detailed breakdown of how well the script argues its perspective evaluated against the broader landscape of consciousness frameworks. Your script's normative framework is its greatest strength. Thank goodness the LLM could catch that. You aren't claiming physicalism is the absolute ontological truth, but rather that it's most plausible, promising, useful, and communicable pursuit based on abductive reasoning, inference to the best explanation. This is a sophisticated and highly defensible position. The logical structure is nice, good, cool. All right, strong use of core theories. Yep. Nice, yep. Powerful hermeneutic argument. This is what we're interested in. Your most effective argument against non-physicalist views is that subjective intuition is not raw data, but an interpretation that itself needs to be explained. The line, the content of the intuition is precisely what needs to be explained, is the core of your case and directly refutes theories that take subjective feelings as a metaphysical starting point. So concrete explanations. Your atom of conscious experience section is excellent, nice. By distinguishing action potentials, the notes from the field potentials, you successfully demystify brainwaves and ground the discussion in measurable physical mechanisms. Which reminds me, I have to make a note here. The point we want to make here is that it's difficult to find an atom of experience if the mechanism that facilitates it is continuous. What's like a word that makes continuous clear that it's continuous in a mathematical sense rather than just like I continue to get mail or something like that. Something where it's continuous in the sense that there's an infinite set of numbers between 0 and 1, which is what I try to... I need to get a better example than that, but... All right. Concrete explanations. Okay, nice. Positioning on the landscape and potential gaps. Your script argues its case very well, but it does so by focusing on a specific part of the landscape of consciousness. The debate is framed primarily as materialism versus panpsychism. Right, at least the beginning was. This is a very effective choice for a video, but it simplifies the full breadth of the academic debate, leaving a few significant areas unaddressed. Whoa. The biggest omission, integrated information. What do you mean I call it out? Don't I literally say that? However, the PCI was developed. Yep. IIT is a dominant mathematical theory of consciousness that the landscape paper gives its own major category for. It's a primary competitor to GWT, and the two are being tested against each other in adversarial collaborations. Why this matters for your argument. Your script critiques theories for starting with subjective intuitions. IIT also starts from phenomenology. It posits 5 axioms that it claims are self-evident truths about experience. It then derives its entire mathematical physicalist framework from them. By citing Tenoni's tool but not engaging with its theory, your script misses a chance to strengthen its case against its most significant non-reductive and phenomenologically grounded competitor. All right, I'll just say, doesn't the script call out IIT by name as specifically disqualified for starting with metaphysical, intuitive metaphysical premises? The question is, should we still give it more airspace? But I don't think so. The real logic is, or the full story is that this PCI was developed by them. PCI actually does help explain or does contribute to an argument for global workspace. And also, it doesn't necessarily argue or lend itself an effective argument for IIT. Because IIT is specifically making a case about the capacity for, I guess, capacity for consciousness, but capacity for distributed, what's the word? Propagation? Distributed, I forget what they used. It's distributed effect, system-wide effect. You know, the idea is that you perturb the system somewhere and see how broad the effect is, or how I'm not sure what the word would be. Man, the issue is I got to study this stuff. Like literally, I just learned this stuff like a few days ago. I think I'm going to need to study it if I really want to actually go on people's channels and talk about it. Like, how funny would that be? I go on the channel and be like, I'm actually not well versed enough in this to have a good discussion here. But we can have this other discussion, which I find really helpful and more practical to the audience. Okay. Addressing the strongest non-physicalist arguments. Your script's argument against panpsychism is that its evidence, spiritual experiences, DMN alterations, is better explained by neuroscience. This is a strong argument against pop panpsychism, but it doesn't address the philosophical arguments for non-physicalism. The philosophical arguments. Philosophers like David Chalmers, whom you mentioned, or those in the dualism camp, don't base their views on spiritual feelings. Right. On logical arguments. My ontological, My argument about ontology and pragmatism specifically addresses arguments that start with logic, which we can make sense of as learned, contextual, etc. Perhaps I need to be more explicit about this within the script, as people might think that the challenge is only against presuppositions against, let's just say, metaphysical presuppositions, whereas I'm challenging any presupposition, any intuitive, even logical, even I should say intuitive presuppositions that might even feel logical. That may. No, I don't have to do that. Okay, that was the second thing. This is the strong. Yep. They base them on logical argument. Okay, the zombie argument is logically conceivable to have a physically identical being with no inner experience, which, if true, means consciousness must be an extra fact beyond. That said, I do specifically. I gotta stop saying specifically. So I do specifically, in this case I can use specifically, challenge the philosophical zombie when I mention that it couldn't exist according to lesion study evidence and my own logic. The idea is that, actually I should say this before. The idea is that a logical argument must still abide by the standards of science. And then I could say, for example, I do specifically challenge. So I don't need that anymore. Nice. Okay. The knowledge argument. Mary, a scientist in a black and white room, can know all physical facts about color, but still learn something new. The what it's like when she sees red for the first time. Okay. While I don't address the Mary scenario, I would challenge the idea of what it means to know in this case. Why are we weighing, prioritizing Why are we... What's the word here? Prioritizing a definition of this that doesn't include the fact of I know what the color looks like. The answer is that pragmatically, our conceptual understanding is contingent, and this leads us to be more compelled by certain definitions of no. Also, I would challenge the idea that all the facts is even intelligible, is even an intelligible concept. Okay, your script's neuroscientific argument doesn't defeat these logical arguments, it bypasses them. A physicalist must explain why these logical arguments are flawed. I do this. But yeah, this is like a... I feel like Chalmers really... It's about conceivableness. It's about whether it can be conceived of. And so I'm kind of arguing that it's not logically conceivable. Like I can conceive of it, but I can't conceive of it in a way where I think it's logical. I can conceive of a philosophical zombie, but I can't conceive of a logical philosophical zombie according to the evidence. This second one's a little more, this is a semantic trick. The nuance of physicalism. Your script advocates for a physicalist view. The landscape paper shows this is a broad term. Your view aligns with materialism, which aims to reduce consciousness to physical processes. You don't engage with non-reductive physicalism, which agrees consciousness is physical but denies it can be reduced to lower level parts. What makes this script reductive physicalism if it also explains its inherent ontological speculation, shortcomings? It can't reduce consciousness down to parts. Okay. It can only reduce consciousness down to concepts, which aren't even clearly should I say determinate? Okay. Final verdict. For its intended medium, your script is nice. It widely narrows. It narrows the vast landscape to a digestible and popular conflict. It successfully argues that the evidence used by many proponents of panpsychism is ironically better explained. Okay. Its gaps are not failures, they are strategic omissions necessary to create a clear and compelling narrative. As the most promising scientific path forward, and it makes the case with precision and clarity. Okay. No, I don't want to entertain the IIT here. All right. How well did I defend? I mean, granted, this is a language model, so it's going to think my defense was good, but... All right. My previous analysis missed that explicit call out. Let's break. Does your script call out IIT by name? Does not mention IIT. Does it seriously not? Am I going crazy? What is happening here? What did I give it? Is this cut off? What? Where are we? This is ontological takeaways. Did its context window run out? Did your context window run out? The quote is... Or did I use the wrong name such that you would overlook this? All right, let's just continue. However, your critique of theories that start with intuitive metaphysical premises is a perfect description. Yep. Begins by positing 5. Yep. And then it builds its entire mathematical framework to satisfy those starting axioms. That's why you don't name IIT. Your argument that we cannot accept theories that begin with... Okay. You do tackle the zombie argument head on. You use empirical evidence from lesion studies to argue against its logical possibility. When you say we cannot remove these and still behave as some sort of philosophical zombie, you're making the exact argument you described. A logical philosophical zombie is not conceivable once you factor in the scientific evidence. So unless I just misunderstand that. You're right that the script doesn't address this, but your reasoning here is classic and robust physicalist response. The argument that Mary gains a new ability rather than a new fact is known as the ability hypothesis. This aligns perfectly with the... Okay, you are challenging the premise that knowing all facts is a coherent concept if facts excludes the know-how of subjective experience. It doesn't even require, like, I guess my argument's not even that you don't need to know how it feels to see that color, but you need to know that you know how it feels. Like, that's a fact that could be reduced down to the words. So once you have that fact and you believe it with conviction, then I guess what happens? You believe, oh, I guess I didn't know. But yeah, I don't know if you could have that conviction without thinking that you've seen it. But also the thing I should also, you know, the other thing I should challenge there is that there's no, like, you can't have all the facts about something. Regardless of how many facts you think you know about something, you're going to learn another fact about it. Especially since the idea of like what constitutes a fact about something is pretty ambiguous. And, you know, I could think a fact about this pen is that I am holding it at 7:15 p.m. today, you know, and that's a new fact that just came about. And at 7:16, a new fact is going to appear in the world, and it's going to be that I'm holding this thing at 7:16 p.m. So, yeah, time goes on, and then you die. That's it. All right, you are correct that okay. Is the script reductive physicalism? This is a fantastic question. The answer clarifies your script's precise philosophical position. No, your script is not arguing for reductive physicalism in the way you're thinking. It's arguing for a more sophisticated position that aligns perfectly with what the landscape papers calls type B materialism. Here's the distinction. Ontological reduction, what it is. Your script is ontologically reductive. You argue that consciousness is a physical process, a product of homeostasis, neural activity, and global workspace dynamics. You explicitly reject any non-physical extrinsic component. Yeah, the script also challenges the idea that we can like make a philosophic, like a ontological statement about what something is. At least that's the implication. But of course, like we have to be pragmatic at some point, and we have to make an argument that we want other people to be able to understand. So, epistemological reduction, what we can know. This is where your script is non-reductive. You correctly identify that your explanation of the physical process is itself a conceptual model. Okay, this is the very definition of type B materialism. The belief that consciousness is a physical process, but that we have an unclosable epistemic gap. Also, the ontological implications include the idea that we cannot, at a most fundamental level, say what something is, which is why we highlight the pragmatic normative aspect, that we ought to act as if it is. Does type B materialism still work with that you're a physicalist about the ontology? Not quite, but yes. Maybe is it a different word? I thought it was integrated information theory. And we even say is speculative according to scientific standards. The answer is no. Type B materialism is not a perfect fit for your more skeptical position. In fact, your view is arguably more philosophically cautious and defensible. Here is a crucial difference. Type B materialism makes a strong ontological claim. Your script stance avoids making that strong ontological claim. You're arguing for pragmatic physicalism or methodological physicalism. You state we cannot, at a most fundamental level, say what something is, but we ought to act as if it is. So pragmatically, obviously, in like in certain situations, we should act as if like we can talk about the truth, right? And we talk about it through like a physicalist lens or an empirical science lens. But philosophically, at the end of the day, we have to take the more speculative position. An epistemological stance that guides a method, not a metaphysical stance about the ultimate nature of reality. You are prioritizing the scientific method itself over any ontological truth claim. And we're leveraging the concepts we seem to have, right? We're not leveraging anything that's concretely true. This is a subtle but powerful distinction. You're saying consciousness is physical, but it's mysterious. Oh, no, you're not saying. Okay, I was like, what? You aren't saying consciousness is physical, but it's mysterious. You're saying we can't know what consciousness is, so our only rigorous path is to treat it as a physical phenomenon that must abide by. I don't know if this. We can't know what anything is. Like it's not that we can't know what consciousness is. Like, separate from other things. It's that like we just understand that our viewpoint is the way it is. All right, this pragmatic stance is precisely what allows you to successfully challenge both the metaphysical idealists and the logical argument. By holding them to the same empirical standards. Okay. I think I'm going to cool it with that one. What do we want to do here? We want to follow this path here. Key publications. This is what we're looking for. Whoa, what happened? What happened? When was this? 9 months ago? What's he working on? ResearchGate? Oh, okay. Never mind. Compositional recombination relies on a distributed corticocerebral network susceptibility to visual hallucinations. Okay, what I want to do is I want to test out my understanding here. Split view. Huh. Yeah, what is the how? Interesting. Oh, it's probably here. Whoa, okay, that's pretty cool. That is cool. Oh, this is really nice. Okay. So yeah, I wanted to summarize the video. I want to go back to that one. True or false, the main presenter's main goal is to create fully functional brains. Oh, can you be more comprehensive? Yo, Jago. Brought you to the gym leg day, baby. Hell yeah. Welcome to the YouTube side of things. I'm kind of just going over consciousness stuff. I decided this is consciousness week. Uh-oh. Oh, that was a rando. Just prepping for this video. We've got a nice beefy script. And yeah, I'm kind of just trying to test it against other ideas. But I think we're pretty resolute here. Okay. Specifically, these cells, blah, blah, blah. Expectation, consciousness. They propose arises when two streams of information interact, causing a burst firing in the cell. Whoa. Let's listen to this.
That have tracked back, 15 to 20 years, showing that one of the main effects of anesthesia is to essentially decouple different compartments within cells in your cortex. So I'll unpack that a little for you. The cortex is the kind of outer layer of the human brain, is kind of the wrinkly outer part that you'll see if you Google the term brain online. It's quite convoluted sheet of these different cells that are all kind of interconnected with one another. And it turns out that within that convoluted sheet, if you were kind of to take a little biopsy of one part of it, or to sort of stick a microscope in one part, you'd see that a lot of the cells are actually oriented vertically, so that on the outside of the brain, you could almost imagine the sort of upper part of a tree, the kind of bushy leaves of a tree are sitting at the top. And then there's these long stalks, a little bit like a palm tree, that go deep down into the brain. And just before the interface between the cortex and the rest of the brain, they have their what's called cell body. It's kind of like the roots of the tree. And it turns out it's really quite fascinating. These different parts of this cell, the top of the tree and the roots of the tree, receive completely different streams of input. So Matthew's actually shown that the kind of sensory inputs that you receive from the world, they're going to be much more likely to hit those bottom parts of the tree, whereas your expectations about what would happen actually project to the top parts of the tree. And when those two parts interact, you actually get a really, really different effect in your brain. This big burst firing of this cell, it just goes absolutely bananas. And it turns out that spiking that you see in the cell when these two streams interact actually coincides with your conscious experience of a stimulus. Now, I say but I mean here a mouse in an animal model of this perceptual experience. So what Matthew's done, which I think is really fascinating, is that he's shown that multiple different types of anesthetic drugs actually block the ability for that expectation and the evidence to match together. And you basically block the ability for this cell to respond in that really big bursty way to those coincident inputs. And the reason this is really, really exciting is it suggests that irrespective of which anesthetic agent you use, a way to block an animal's ability to actually combine context with input actually can, turn on and off conscious experience in a really physical way. So in my group, then what we've done is we've sort of tried a little bit like a relay race. A lot of science is a big relay race, right? You take the baton from a brilliant group that's come before you who did the same thing for people that came before them, and you try to just inch it forward a little bit. And so what we've tried to do is essentially take this concept of these different streams of information coming into a cell, being able to switch it on and off, and to build that into little models where we can then ask, okay, if we have a little model of this system and we ask what kinds of things can cause that switch to open or close, or we ask what happens when a group of these things all work together and the one that's bursting now can impact another one, it can impact another one, etc. All these kinds of really, really difficult things to imagine, but very, very easy to write into a computer program. We can then ask, what is the signature of their effective kind of organization in different ways? And it turns out, to cut a long story short, that you can recapitulate a number of different signatures that people have found empirically when they look at someone's brain that is in a coma versus awake. The difference between those can be recapitulated in our model in a really, really exciting way. So it suggests that you can take something really physical, like a cell that is combining or not these different input streams, and you can scale it up to actually understand the kinds of things you can measure as someone in a hospital, or you and I sitting here having this conversation. And that's what we're really excited about, is this ability to essentially take something that seems so ineffable, right, our conversation, and build it up from a biological basis.
And to see if I can kind of understand it, it's interesting that you kind of say there actually is this need for the expectations from ourselves, and the sensory input seems kind of actually important for consciousness, such that, if you block, you can still have the expectations maybe, if there's a sensory input, what can you do? And equally, if there's sensory input, but then you're not really able to make sense of that and think, well, would you, kind of expect to see how should I be interpreting what the sensory information? Then there seems to be kind of no consciousness. So, and then what you're doing is kind of, if we can actually look at, okay, that's like an important thing, and then what more generally is going, a broader scale is going on in the brain, and then what more can that tell us about consciousness if we can kind of model that, and then we're sort of seeing what dynamics more broadly are important for facilitating consciousness. So, tell me a bit more about your work there.
Yeah, so it's important to state at this stage that this idea of expectation and evidence matching leading to consciousness is not a new idea. That's been around for some time, and there's some really beautiful work.
Yep, sorry about that. This is like some cutting edge stuff. I've been like searching all week so far for like a YouTube video that actually covers like a modern look of consciousness, and yeah, I knew 179 views. I knew that was it. I knew that was going to be the one.
Victor Lama had some really lovely work on this that I read back when I was a grad student. That was quite inspirational to me. But again, and Matthew had also done a lot of work to that end before we came along. The part that we're trying to add to this sort of very complex puzzle is taking very seriously this notion of sort of the organization of the brain being particularly useful for some of the things that we're capable of doing. And so if you look at this notion of these cells that can integrate your expectations with the evidence that comes in, it turns out that they're connected, and that coupling between these two compartments is influenced and kind of modulated by a number of other structures that have also been shown by others to be deeply important for consciousness. So one of them is the thalamus, which is a really deep structure in the brain, which we're really interested in. And then the other one is known as the reticular activating system, or it's part of what's called the brainstem. So these structures are much, much deeper in the brain than the cerebral cortex. So the thalamus is kind of a central processing hub, and then the brainstem is kind of the core, really deep kind of in your neck that supports many really basic physiological functions. So there's parts of your brainstem that control your heart rate and control your breathing rate and your ability to balance. It also has the highways that send all the messages from your body up to your brain and your brain back down to your body. So anything that comes in or goes out has to go through the brainstem. But interspersed in amongst all of those different circuits are this really interesting set of regions, different nuclei, neurons, that project really diffusely up into the brain. And in particular, they actually are projected to areas that help this coupling turn on or off. And so we're really interested in whether or not different elements of this system could actually facilitate different types of emergent activity in a system that was built of these little toys. So you can imagine this a little bit like playing with Lego and setting the puzzle, the Lego piece to be this particular neuron that can couple things together and do this interesting burst firing. What we're essentially doing is saying, what if we built a model like that versus the way that people would traditionally build models, which is just that each neuron sums up all of its inputs and then does a little spike. That's called an integrate and fire neuron. We've got a different type of a sort of Lego block at the start. And the question is, can that do really interesting things? Can that compute in different ways? Can that provide different types of kind of computational signatures? And it turns out that it can do lots of very interesting things that are coincident with predictions that people have made in the community from a completely different perspective, thinking about what would be the benefit of being conscious versus not, or what would the mechanism of a conscious thought versus an unconscious thought be? And we can kind of find some of those signatures using our model in a way that we find really, really exciting.
It's interesting that one often thinks about consciousness and the higher order capacities of humans are sort of residing in the cortex and in the outer layers of the brain. But if you're saying, go down deeper into the sort of like near the brainstem regions, and see actually, okay, there is consciousness, and so actually, how are they mediating different kinds of consciousness? And also, I mean, tell me more about, so cognitive scientists, and you say have this model of neurons. Often they sort of they fire at a certain point once sort of they reach a threshold, or I mean they have weights, and then the way you're thinking about it is, well, what is this different way of thinking about it, of how neurons could fire, and why would you think about it like this? What
Yeah, it's a tricky one to get into on a general podcast, but we'll do our best. So a lot of really brilliant insights have been required to get us to the point we're at now in computational neuroscience. And I don't have time to cover the sort of full history, but one of the really huge insights that really helped computational neuroscientists was this notion that you could take the complexity of a neuron. If you looked at one of these things under a microscope, you'd feel like you were kind of walking through the forest looking at an individual tree and trying to describe it. And neurons have very characteristic components to them. They have a cell body. They have a projection that leaves the cell body, which we call an axon, which is often thought to be the kind of output of the cell. And they've got a set of what we call dendrites, which are the kind of receptive parts of the cell. And neurons come in all shapes and sizes. Some of them are very simple. So the cell body is covered in little dendrites.
I'm curious if these dendrites are like are effectively circuits in some sense, or if they're just collecting charge. Like I'm wondering if there's any logic in the exact structure of the dendrites.
That look like little hairs, and the output of an axon is a single axon. But some of them are deeply complex and have this really, really intricate architectures. But
because dendrites they're taking in inhibitory signals as well as excitatory signals, and which once those clash, it affects either the neuron firing or not firing. But yeah, does that I guess I wonder, is the logic there happening? I just imagine it happens in the nucleus. Let's ChatGPT this. Does any quote unquote logic happen? How would I say this? Within a neuron's dendrites, or is it all happening within the cell, the nucleus, as like a specialized chemical reaction? I know they model dendrites with circuit type elements. A mutual friend of ours was going to study this. Oh, nice. Inhibitory signals, excitatory signals can be thought of like gains, perhaps. Yeah. Yeah, once again, this is why I think the analog system, I would say it's not even a metaphor, right? But like just that perspective, it really works here. Yes, some logic does indeed happen within dendrites. It's not all centralized in the nucleus. The nucleus handles gene expression and long-term regulation, for example, making new proteins. But moment-to-moment information processing, what we might call, analogize to computation or logic, occurs largely in the dendrites and axon hillock. Wow. Dendrites are the neuron's main input structures. They receive synaptic inputs, neurotransmitters released from other neurons on thousands of tiny spines. Each of these synapses changes the local membrane voltage slightly, right? These signals are not merely summed linearly. Dendrites have voltage-gated ion channels and can perform nonlinear operations, things that resemble logical and or not combinations in simple models. Wow. For example, if two nearby synapses fire together, the resulting depolarization can trigger a dendritic spike, greatly amplifying the signal, a kind of coincidence detection, and inputs on separate branches may not interact at all, a form of spatial gating, independent subunit. And then some dendritic regions inhibit others, a form of local knot operations. So in modern computational neuroscience, dendrites are seen as active nonlinear computational subunits, not passive wires. Nice. Where the output logic happens. The output of these local computations spread toward the axon hillock, the region that decides whether to fire an action potential. Okay. The hillock integrates and weighs all incoming dendritic signals and executes an all or nothing threshold function. The most basic logic gate in a neuron. Right. So the decision's pretty much already been made by the time it's... actually, I shouldn't say that. Like, half the decision's already been made, and then half of it is whether or not there has been enough stuff that comes through that it reaches the threshold where it's like, boom. Sounds like a mixed signal system. I don't know what a mixed signal system is. Mixed signal system. Systems integrate both analog and digital circuitry into a single chip or within a single system to allow for interactions between the continuous analog world and discrete digital processors. I guess, yeah, I'm wondering where you're finding the digital here. Like in this case, it's you know, you could think of these as functionally and or not, but really what's happening at each of these stages are, I guess, chemical reactions where like charge is literally, I don't know enough about charge, but like charge is literally canceling things out, or it's like it's acting in such a way that you'd expect a digital and or not gate to act, but it's not exactly that. Like I imagine there are, like I imagine it's messy in such a way where like perhaps different you know, dendrites come through to a gate and it's like effectively a not gate, but a little bit gets through. Right, digital from the logical expressions likely. Right, yeah, like the way I see this is it's like it's quite messy in like what's actually happening at the most granular level. Like it's literally just yeah, neurotransmitters carrying charge. These things are having I guess chemical reactions. I mean, granted, I don't know the chemistry well enough, but yeah. Okay, so the thing I want to know, the next thing I want to know is what the nucleus does here. The nucleus isn't involved in real-time signal logic. It governs slower biochemical Okay, so I guess I didn't realize the nucleus wasn't involved in there. Yeah, it doesn't take part in rapid information. Okay. The thing I'm wondering is what he means when he says that the singular neuron is taking in stimulus information or stimuli information as well as expectation information. I heard James Mac Shine mention that a singular neuron can take in both stimuli information and expectation information simultaneously, which can affect rapid bursts of action potentials. I'm guessing that what occurred here is complex logic within the dendrites. I guess I didn't quite realize that that dendrites were so dendritic systems. Oh, I'm saying I'm using a T there. Dendritic systems were so complex that they could both take in complex signals like these and handle all this sophisticated logic. Like determining which combinations should affect such rapid large bursts. Was it large rapid bursts or rapid large bursts? I'm not sure. I think it was large rapid bursts. Honestly does remind me of an ADC type system. There's a deep abyss here. Lots to interpret. Oh, analog to digital converter. Oh, nice. Right, but yeah, I imagine the digital converter, regardless of what like how messy it is, it just says, okay, you know, this is effectively a NOT gate, so let's just run it, and you know, whatever residue we just don't care about, it's negligible. Same with the AND gate, like we don't care about how much is coming through. Okay, let's unpack this carefully because what you're describing touches on one of the most exciting frontiers in neuroscience, how single neurons can integrate different streams of information, sensory versus expectation, or bottom up versus top down through dendritic computations. What James McShine is describing, Shine and others have shown that single cortical pyramidal neurons, especially in the cortex and thalamus, can simultaneously receive bottom-up sensory inputs, arriving on basal dendrites near the soma cell body, top-down predictive or contextual input arriving on apical dendrites, the long dendritic tree that reaches toward the cortical surface. Man, yeah, so these dendrites are so long. When both arrive together, these signals can interact non-linearly in the dendrites, so not just add up, but trigger special events like calcium spikes or NMDA spikes that dramatically boost output firing. The mechanism, dendritic logic and coincidence detection, you can think of this as logic happening inside the dendrite when sensory input, bottom up, is active, but the top-down apical input is quiet, modest firing, or maybe none. When expectation input, top down, is active, but sensory input is absent, no strong effect, prediction without confirmation. When both inputs coincide, the dendrite generates a local calcium spike that massively depolarizes the soma, burst firing. It leads to burst firing. That burst is a decision that both bottom up and evidence and top-down expectation align. Okay, so we also have to ask if this is what the predictive processing people are leveraging. So I have to go to my necessary research section. We've got Anil Seth and we got Clark. What's Clark's first name here? Andy. Is this... I should say, does Anil Seth and Andy Clark, do they leverage these findings when building a predictive processing perspective? And like, is this essentially outstanding evidence for a predictive processing framework perspective? why dendrites can do this. Dendrites aren't just cables, they're semi-independent processors. A single large pyramidal neuron can have dozens of dendritic subcompartments, each with local voltage-gated calcium or NMDA receptor dynamics, independent excitability, the ability to produce dendritic spikes that may or may not propagate to the soma. These subcompartments can perform distinct computations in parallel, combining or gating different streams of input. The neuron as a whole is then more like a small two-layer network than a single logic unit. Nice. Something that's interesting seems to be the time variant nonlinear nature. If these dendrites carry a signal, the next time they carry the signal will be different, I imagine, stronger. Yeah, I think that's the other thing. It's like constantly activation is affecting the strength of synapses. And I think that involves both affecting the axons and the dendrites. So, yeah, it's insane. It's like not only do we have these circuits, but these circuits are changing over time, constantly. And that's also an analog system. Like it's a continuous system there. So it's ridiculously complicated. Like it's so complex that it's just unbelievable. Okay. And then, yeah, the thing that I learned recently is that, like, when a neuron fires, if it fires a bunch in quick succession, in quick enough succession, it undergoes, like, a phase transition to a more excitable state, so which allows its propensity to fire to be higher. And when we look at like state space in a brain, so like the information that's like flowing, it's like main driver is which neurons are in that excited state. So yeah, the thing it was so embarrassing. The thing I learned this morning is that like when you look at I think it's an EEG. Like when you look at those scans of the brain, you see a loop going. I always thought that was the action potential. Like that was all the different neurons firing to the next one, and like that's the loop. But really, it's the excitability that's creating those electric fields which show up. But that isn't necessarily like in line with specific action potentials. Now, obviously, when a neuron is in that excited state, it's going to be firing off action potentials much more rapidly. So, yeah, like, but that doesn't mean that a neuron that isn't in that state isn't firing. It just means that, like, that's kind of keeping the rhythm of a bunch of neurons firing. That blew me away, just because I just didn't expect that level of orchestration. So I am going to include that in the video because I think it's really important. But we have to keep it accessible. I'm trying to keep it as accessible as possible while still going into this state space stuff. Voltage controlled amplifiers, nice. Hell yeah. Yep. Yeah. What was funny is that Hank Green had like a video on language models or AI. Where do I have this? Hank Green YouTube. Yeah, and he's got this. He's got a thumbnail that says "This is alchemy." On ChatGPT isn't smart. It's something weirder. When literally our brain is alchemy. Like our brain is just straight up chemistry. So I don't know what he means by that, or why that would be particularly apt, but it's Hank Green, so he can do no wrong. All right, what do we got? The large rapid bursts. Yep. and I imagine large rapid bursts pretty much like I'd imagine they almost immediately affect which neurons have that phase transition. They affect the field potential. Electrochemistry, fancy shit, yep. Yeah, it's just crazy stuff. Absolutely nuts. I'm glad I don't have to go deeper than this. And I mean, granted, I keep going deeper, but I don't think I have to go deeper than this to learn the functional aspects of the brain. Except now, now I'm learning about dendrite dynamics. So who knows? Who knows? I'm probably overlooking something that. Yeah. Oh, so the other crazy thing is neuromodulators. So like neurotransmitters are they're going from one neuron to the other, right? Through dendrites and then out through the axons. But at the same time, certain parts of the brain are literally like releasing neuromodulators, which are pretty much the same thing. Like a lot of them are also neurotransmitters, but they're just not now traveling like from neuron to neuron. They're being like released diffusely, and they're affecting the excitability of neurons in that proximity. So like you've got another dynamic that's affecting this whole system. So it's just absolutely bonkers. Yeah. All right. These bursts are energetically expensive but highly informative, often driving downstream neurons in synchronized networks. In other words, the neuron isn't just relaying information, it's computing the relationship between expectation and sensation in real time. So I just assumed that logic happened only in broad neuron systems, but I guess it's happening within a neuron as well. I should write this down, actually. I always thought that this type of logic transpired across neuron system state space. How much logic would you say is happening within the dendrite versus across neurons? Because there's logic in both ways, so it's very difficult to figure this one out. Expectation minus sensation equals error signal. Does this say that? The conceptual leap. You're right to be surprised. It's a profound shift from the old neuron as a simple adder model. Current understanding suggests that a single cortical neuron can perform complex, context-sensitive, hierarchical logic operations thanks to the nonlinear and compartmentalized properties of its dendrites. That's why some scientists talk about neurons as microprocessors, AO, or multi-input integrative units, rather than simple threshold gates. What else did I want to ask here? If I wanted to, I probably should just use the language model rather than read a book here, because I think going into a book, I would go way too deep. An error signal is used to drive feedback networks classically. Oh, okay. Yeah, I'm curious if that that mirrors or matches onto the predictive processing folk who do talk about prediction error as some sort of error signal. Yeah. I wouldn't be surprised. Okay, let's take this in steps because you've raised two related but conceptually distinct issues. Where the logic actually happens within versus across neurons. So it's not where, but how much is happening. I'm curious just like where most of the logic is happening. How this dovetails with predictive processing theories from people like Anil Seth and Andy Clark. How much logic happens within dendrites versus across neurons. A good way to think about this is as a nested hierarchy of computation. So dendritic branch slash compartment. This is tens of microns. That's the spatial scale. Wow. Mechanism, nonlinear local integration. Right. The type of logic would be fine-grained sub-symbolic logic. Coincidence detection, gating, subunit computations. Right, but I want to know functionally what kind of logic. Whole neuron. Whole neurons, the summation and threshold at soma / axon hillock. Because really the dendrite is tackling the very last bit of logic that could take place for the neuron. Otherwise, you're talking about, you know, more large scale logic dynamics. But here it's like, you know, multiple neurons are affecting inputs for this neuron. So the type of logic would be neuron level decision, spike / no spike, temporal. Okay, so this is talking mechanistically the type of logic. I'm trying to ask what type of logic functionally. The microcircuit, dozens / hundreds of neurons. This is recurrent connectivity, inhibition / excitation, balance. Because yeah, like a neuron could be operating for a microcircuit here as specifically like inhibitory because it has downstream neurons, or it could, you know, obviously operate as excitatory. Pattern competition, oscillation, state transitions, and then network / population, long range recurrent loops, feedback / feed forward, global dynamics, attractors, inference over state space. Brain also doesn't seem clocked in any digital sequential sense. Yeah, how does clocking work with digital systems? Or like, what does that concept mean? Like, is it clocked in a sense that like a CPU it's running at a certain rate? I guess that's what it would mean, right? And then you overclock. Okay, yeah. So yeah, I think that I mean, I guess weirdly the brain ends up with the same frequencies, like my brain and your brain are probably I think, you know, firing in the same frequencies. I think that's the case, right? Don't brains just follow like gamma, alpha, beta wavelengths? Or not, wavelengths isn't the word, frequencies. Oh man, I'm being summoned. I think I have to end the stream. I forgot that Mr. Barr and CJ were doing a Baldur's Gate tonight. Yeah, that's why I said ours together. We're like at a, I'm not saying ours are the same as everyone else's. I'm just saying ours are the same at a higher level, you know? All right, I'm gonna have to finish this thought process tomorrow morning. I've been literally every day I've been waking up and just learning about the brain. So I'm kind of going crazy at this point. Okay, let's just save that. But I'm pretty confident about this video. I think it's going to be an absolute banger. So we'll see. We really out here. Yep, I'll tell him I said I'll tell him you said hi. Have Have a good rest of the gym. And hopefully I'll see you later, actually. Or in the flesh. All right, see you later.